Hello, so today we are going to continue on weekly contest, biweekly contest 101. The second problem is find the substring with maximum cost. So what this problem says is, this is the second problem. It says that we have a string S and a string of chars of distinct characters, and we have an integer array of values. And these values have the same length as the chars array. And we define this concept of a cost of a substring, where it's the sum of the values of each character in the substring. Okay, so for example, here the characters, we have just D, and the value for D is minus 1000. And the value of so the cost of the substring is the sum of the values of each character in the substring. And then the value of each character is either, if the character is in this char string, then it's the value at the same index that is in chars. So for example, here B is in the characters array, chars string, and the index is 1, so its value is at index 1 in vals, right? So that's the idea here. Now if it's not there, then we just use the index in the alphabet in the they are all lowercase, so we use the index in the alphabet from A to Z. But we do it in a way where it's one indexed, which means basically A has index 1, B has index 2, C has index 3, and you get the idea, all the way to Z, which will have index 26. So this is how we determine the value of the character, either using this chars array, or using the alpha index in the alphabet. So yeah, we just want to find the maximum cost among all substrings of the string S, and the cost of a substring is just the sum of the values of all the characters in the substring. So that's the idea. Now let's see how we can solve it. Okay, so how do we handle this? Well, we have the first example here. The first thing we can do is actually, because getting the value of a character has multiple conditions, 2 conditions, we want to try to simplify that. So let's just create an array. So what the problem says is that it's one of 2 cases. If the character is in chars, then we can just use the index. Let's say it's I here. Then just we can so we can just use the index and get it from the vals array. If it's not in it, then we just take the index in alphabets. So let's just normalize this. So the first thing is, let's take care of this one, and then and then we can update with the values from this. So what does that mean? So we can just create a values array, right? The problem says we only have lowercase letters, right? And so let's just have these values be in an array, and they will be starting from 1, because that's what the problem says, 2, 3, 4, all the way to 26. Now, given a character, let's say B, for example, how do we know which index it is? Well, that's what we use, ord of that character minus A. This gives us the index. So what we can do here is, then just using this, we get the index, and we can check it in the values. Now, these are the default values. The second step is we want to update with the values from the vals array, right? So we can have the proper one. And so how do we do that? Let's just take it for our array here. We have just D, right? And so we will just replace for D, which would be A, B, C, D. So D is index 4. So instead of 4 here, we'll replace it with the value here. So this would be, right? And then the other values will stay the same. So 5, 6, right? And so that's the only thing we'll change here. And once we do that, the problem becomes easy, because this is our string. So let's take that string ADAA, right? So let's just replace every value. If we take its every character, if we take its value, so the value of A is 1, the value of D is minus 1000, the value of the other A is 1, 1. Right, and so the problem becomes here we are looking for a substring where the cost is the max, right? And so if we look at this array, what we are looking for is actually just the cost of the max sum of subarray. That's exactly what we are max sum of subarray. That's exactly what we are looking for, because this is the cost for the value of each character, right? And the cost of each substring would be just the sum of that substring. And that can be solved with the known algorithm, which is Cadane's algorithm. Okay? And the main idea of Cadane's algorithm is that you keep track of the max ending at each position I as you traverse. And then you keep track also of the max overall, right? And so what that would mean is something like this. So we would have max ending, let's call it here. This is the notation for starts out as 0. And then we would have the max so far, which is the overall max. And the idea behind Cadane's algorithm is whenever you keep adding the values, but whenever the sum, which is the current sum, which is ending, the max ending here, whenever that's negative, right, we reset it and we restart from position I. Now, what's the reason for that? Well, it's because if maximum this value here is less than 0, right, from adding the values as we go, then if it's less than 0, if we add a value to it, then that value, the sum would be smaller. So instead of doing that, let's just start from the new value, right? Because let's say the max so far is -4 and the new value in the array is 5. Okay, so maybe the array is like -2, 5, right? So the max ending at this position, right, is -2. And then when we go here, if we add -2 to 5, this is going to be -3. It's better for us to start from 5 and just take this substring. So that's the idea. So let's apply it here to our substring. So in this case, we'll start out here. So we'll start out here at the first position. So the max now, the ending here, so we'll just add the value of 1. Since it's bigger than 0, we'll proceed. And now the maximum so far instead of 0 is 1. Then when we go here and we do 1 minus 1000, that's minus 999. Well, that's less than 0. So Cadane's algorithm says instead of putting that there, let's just start from 0. Okay? And the max so far doesn't change since 1 is bigger. And now this basically means we will start a new substring from the next element. And so when we go to the next element here, 1, so plus 1 is positive, so we add it. It's still, the max is still the same. We go here, we add 1, so it's 2, still positive, and so the max is 2. And so now the maximum cost we return is 2, and this is the subarray with the maximum sum. And actually that maps to this because this is the substring with the maximum cost, right? So that's roughly the idea. We first put both of these conditions in a one value array and then just traverse this. We can of course convert it to an array first and then get the maximum sum, or we can just do it as we are traversing the string. We'll see that in the implementation, but this is roughly the idea here. Convert to values and then use Cadane's algorithm. Okay, so let's implement this and make sure it passes. Okay, so let's implement what we saw in the overview. So first we need the values for all the lowercase alphabet. So since we start the index from 1, we are going to do I plus 1 because the range will start from 0. So this would be 26, right? This is the number of lowercase letters. And now we want to update with any characters that are in char's string. So we will just go through the length of that string, right? And then we will just get the index of the character. The character is just chars at position I minus, so this will give us the index in the values array. And we will just replace that with the vals because that's what the problem says, is if it's in chars or string, then we should use the value in vals. That's what the problem says. And now we'll apply Cadane's algorithm here. And so we'll just go through the characters of the string, right? And then for each character, we want to get the representation, which is the value of that character, right? So that's in the same way we did here. So that's going to be like that. So this will give us the value. And that value, this is as if it was an array, right? This is what we are going to add to our max ending here. So let's actually max sum ending here, let's call it. And then we'll have max sum so far. Or you can call it cost if you want. So this is the one that we are going to return at the end. And max ending here, we add the value. Now, if the sum became negative, we should reset it, because if we progress with this sum, it will only decrease future sum values, right? And so that's why we reset it here, and we restart at the next index or the next character. And then each time we want to check if this is if this max ending sum ending here is actually the best one. And so we can just do that by getting the max, and that should be it. Pretty straightforward. And so let's run this. Looks like, yeah, it's or not order. Sorry about that. It looks good. Let's submit. And that passes our test cases. Now, in terms of time complexity here, we are, of course, doing this as the length of chars, which is 26. So this one is constant. And then we are doing this loop, which is the length of string s. So it's, yeah, not constant. So O of n, if n is the length of s. And that's pretty much it. So it's O of n time. Now, in terms of space, we are using these values, which is constant because it's O of 26. And then the rest is just variables. So it's O of n time overall and O of 1 space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.